In this lecture, we will discuss how to remove left recursion in a grammar. So first of all, let's see some terms. What is recursive grammar, or what is left recursion, or what is right recursion? So, if a grammar is of the form A tends to alpha A beta, where A is a non-terminal and alpha and beta can be terminal or non-terminal. Alpha and beta can be the string of terminals and non-terminals. Then the rules of this term are called recursive rules, right? Because we are having the same A is occurring in the middle of the right hand side. So repeatedly we can apply this rule. Next is left recursive rule. See, if a grammar is having left recursive rule, then we call it left recursive grammar. Similarly, if a grammar is having the recursive rule, then we call it recursive grammar. And if a grammar is having right recursive rule, then the grammar is called right recursive grammar. Now look at this. Here the rule of this form is A tends to A alpha. Here A is occurring at the left hand side of the rest of the string. That's why we are calling it left recursive rule. And the grammar which are having this type of rule is called left recursive grammar. Now look at this. This is rule of the form right recursive. Here A is occurring, we have A tends to alpha A, and A is occurring at the right hand side of the rest of the string. Then this type of rule is called right recursive rule. In the grammar which contains right recursive rules, the grammar is called right recursive grammar. Now the productions of the form, if we are able to derive some string of terminals and non-terminals from A, then we call it A production. Means A is deriving this string. If we have a non-terminal on the left hand side, then we call as B production. So these kind of productions are called A production, and these kind of productions are called B production, where A and B are there at the left hand side of the production rule. Now, what happens if we remove the left recursive rule? Does the grammar change? Does the language change? No. Neither grammar changes nor language changes. Let's see. Suppose we have a grammar G is equal to NTPS. It is a context-free grammar, and this grammar have rules of the form A tends to A alpha 1, or A tends to A alpha 2, or up to A tends to A alpha R. Means we are having R rules here, right? And all are left recursive, cause here A is occurring at the leftmost side of the entire string, right? We have some more A rules, some more A productions. A tends to beta 1, or A tends to beta 2, or A tends to beta up to beta S. So if we have these type of rules, then we can remove the left recursion, and we can introduce, when we remove left recursion, then we introduce right recursion. Now for when we convert it, then what happens? The generated grammar includes some new non-terminals. Suppose here we are introducing a new non-terminal Z. Now the new grammar will contain the old non-terminals and a new non-terminal, right? Now if we have a rule of type A tends to beta I, then this type of rule is converted into A tends to beta I and A tends to beta I z. Okay, and if we have this type of rule, this is non-left recursive rule, it is converted into two rules, and this is left recursive rule, this will be converted into these two rules. Rule is of the form A tends to A alpha I, then this rule will be converted into Z tends to alpha I and Z tends to alpha I z. Here the value of I lies between 1 and R, and here see, from this we have R rules here. That's why we are using this condition that I is lying between 1 and R. Similarly, we have these A rules up to beta S. That's why this I is varying from 1 to S. Now, if we convert the left recursive rule and we convert it into right recursive rules, then the language will be the same, or the language accepted by the grammar will be the same. Suppose we are considering this rule S tends to when we replace one left recursive rule, then we introduce two rules. See here we are introducing two rules, here also we are introducing two rules. So for removing one rule here, we are introducing four rules, right? So if we replace R plus S rules, then we introduce 2R plus 2S rules to the grammar, right? Let's take an example here. Let's see whether when we convert this grammar from left recursive to right recursive, the language will be changed or not. Let's consider this example. Suppose A drives this string. This is A drives beta j alpha in minus 1 alpha I1. From the previous grammar, we have the rule of the form A tends to A alpha. So starting from the A, we can drive A tends to A alpha. We can drive A alpha I1. We can use this rule. Now from alpha, we can drive any string, whatever the alpha is driving, right? Again from A, we can drive A alpha I2. Similarly, from A, we can drive A alpha I3 and so on. And finally, we can replace this A by beta j, right? We have the rules of the form A tends to A alpha I1 or A tends to A alpha I2 and so on. And we have rule A tends to beta 1 or A tends to beta 2 and so on, so that we can replace here A to beta j. Now the string formed will be bj alpha in up to alpha I1. So this is the string formed with the previous grammar. Now if we convert the grammar in which all the rules are there in the right recursive form, then what will happen? See, all the rules of this form are, we have A tends to beta I, then all A tends to beta I rules will be converted into A tends to beta I and A tends to beta I z, where I varies from 1 to S. And similarly for all the A tends to A alpha rules, we convert these rules to Z tends to alpha I and Z tends to alpha I z, where I varies from 1 to R, right? Now apply these rules. Starting with A, we can derive beta j and z. We can derive it. We have this A tends to beta I z, right? So we can replace with beta z and z. Now this z can be, because we have a rule, A tends to beta as well. Now we can replace it by, this z can be replaced by alpha in z. Again it can be replaced by alpha in minus 1 z, and so on. And finally this z can be replaced by alpha in. So the language here will be same. Now let's take an example here. We have this grammar, S tends to SAB and S tends to SB. Next rule is S tends to C and S tends to D, and we need to remove the left recursion rules here. Now when we remove left recursion rule, then we need to introduce one non-terminal. Here we are considering that Z is the new non-terminal which is to be added to the set of non-terminals. Now as we know that for each rule of the form A tends to A alpha, we derive two rules, Z tends to alpha and Z tends to alpha Z. And for each non-left recursive rule A tends to beta, we derive A tends to beta and A tends to beta Z. Here we have two recursive rules. One is S tends to SAB and S tends to SB, and two non-recursive rules, S tends to C and S tends to D. So when we convert S tends to ASB, the new rules will be, see here, this is of the form A tends to A alpha. The form is A tends to A alpha, where alpha is AB here, right? So for A tends to A alpha, we convert it in Z tends to alpha. So here we will be having Z tends to AB. The second rule is Z tends to alpha Z. So we will be having Z tends to ABZ. Here AB is alpha. Similarly with this rule, here this is also in the form of A tends to A alpha. Here alpha is B. So we will be having the rules Z tends to B and Z tends to BZ. Now for these non-left recursive rules, S tends to C, we have again two rules, S tends to C and S tends to CZ. And for final rule, S tends to, it should be S tends to D here. It should be S tends to D here. So this is for S tends to D. We will be having two rules, S tends to D and S tends to DZ. So finally we have 4 S rules and 4 Z rules. Finally, when we convert this this grammar into non-left recursive, then we have, see earlier we had 4 rules and we converted, when we converted it into right recursive, then we are having 8 rules, right? Now let's see what is substitution rule. Substitution rule is, we have a grammar G is equal to NTPS is a context-free grammar, and we have a production A tends to alpha 1 B alpha 2, it is a production in P. And we have some rules. B tends to beta 1 or B tends to beta 2 or B tends to beta 3 and so on up to B tends to beta R. We have some these B productions. Then what can we do? We can remove this rule and we can introduce some new rules by substituting the values of B one by one. Here in place of B, I can use either beta 1 or beta 2 or beta 3 or beta R. So in place of this rule, I can use alpha A tends to alpha 1, beta 1, alpha 2. See, in place of B I have used this beta 1. Or I can have A tends to alpha 1, beta 2, alpha 2 and so on. So this is the substitution rule. Thank you.